Hello, I'm Christy Patton-Lukes, a chemical engineering professor at Missouri S&T. This video is going to look at getting started with AspenPlus. You may wish to download this document that I've created that goes through this tutorial with a little bit of detail, lots of clips to show you quite what we're doing. We're going to be using Aspen to solve a problem that's a simple flash. And in particular, it's this problem here. Consider a flash separation of methanol and 1,4-dioxane at 1 atmosphere. The feed is 30 mol% methanol flowing at 100 kilomoles per hour. We want a liquid product that's 20 mol% methanol. What is the composition of the vapor phase, and what are the flow rates of the two product streams? Let's look at how Aspen can be used to solve this. So I've started Aspen. I hit New. Sorry, I did that before you were on. Blank Simulation and Create. Aspen, remember, is going to be a little bit slow, especially if you're using VMware. Another thing I need to point out is that I'm using version 10. If you are using a different version, it's going to look slightly different from time to time. But it's going to basically start out with your component selection. And the easiest thing to do is come over here into Component ID and start typing your chemicals. And so we want methanol. Just typed it in, hit Enter. And 1,4-dioxane. And it complained. Okay? So that's not what I want. I could keep trying different things until it came up with it, or the easiest thing to do is use find. And I know I want a dioxane, but how do they do the 1,4? There's various ways that they could have described that. So let's just simply type in dioxane and see what it comes up with. And again, this is fairly slow. There's 1,4-dioxane. I'm going to just highlight that one and say add selected compounds. I hit it twice, sorry. All right, I'm done. I'm going to close this out. And we see that our components, I've got the two components I need, and these are all blue checks. But methods still has the little red circle, the dreaded red circle. So if I look at that, the specifications are needed. Now I could have just clicked on methods here and it would have come up with the same screen. We'll do another lesson later that's going to show us how we can come up with, make a better choice of what our model is, and you can use the methods assistant also. But the method is going to be what math model are we going to use to describe all of these properties for our substances. I'm going to do the Suave Red Liquang. So just click on the little arrow and go browsing through until you find the one that we want. Here's SRK. I'm going to go with that. And I will, for today, just say that's good because I've got all blue check marks. Okay? I now want to know whether or not this was a good choice. There are lots of ways that I can do that. One thing might be that I could come in and if I knew, say, binary interaction parameters, I could come in and I could edit these. But we're going to do something even simpler. I have some data. If we return to that Word document, the data for this, we'll find it here eventually, is this graph here. And at 1 atmosphere, methanol and 1,4-dioxane look kind of nearly ideal until you get to the high compositions of methanol, and then it looks like it probably forms an azeotrope. We're going to ask for Aspen to develop this picture here for us. All right, so how do we do that? Well, the technique basically is that on the Home tab, I'm going to look for the Analysis group and then find the Binary Analysis. If I click on that, and wait, my graph was of TXY data, so that's what I want. But there are other choices. So Gibbs energy and PXY are my other two choices for binary. These are my two components. Component 1 is methanol. And this looks, pretty much like what I'm wanting to do. So let's just run our analysis. And we have the picture here. And it does look more ideal at this end and a little pinchy at this end, not quite showing the azeotropic action that I saw in my other diagram. But my compositions are down in this range down here where it seems to be close to what I had. Now, I can do better, to be honest. Here we see them side by side, and I could do better, but this doesn't look like it's too bad as long as I stay safely down at this end. So I'm going to accept that and return to my Aspen. If I did not like this, I could come back into Methods, Specifications, and I could choose different methods, run the analysis again until I found something I liked, or I could choose parameters and change binary interaction parameter values until I found something I like. At this point, everything on this screen seems to be good, indicated by the little blue check marks. So I'm going to move to my simulation. Okay, I have a blank screen here. This is my flow sheet. And what I want to do first is add a block. A block is the mathematical model for the process. I'm doing a flash, so that's a separator. And I have several choices here. I want flash 2. It's going to have 2 outlets, so for vapor and liquid is the easiest way to use this. I can click here and look at different ways it'll draw the picture. The picture really doesn't matter. The math behind these is going to be the same. So I'm good with that. I'm going to come up here, click, it adds this. Now if I click again, it's going to add another one. I really don't want to do that, so I'm going to now go back to click on the little arrow that takes me back to mouse mode, and I'm going to delete that block. If I click on material, I can add a material stream. So I'm going to add my feed. I'll start it over here and bring it over here. Click again, and it has connected to my block. Sometimes we miss. You can tell whether or not it's connected. If it's connected, there's a little black arrow that's just kind of a single line. And if it didn't connect, it's going to terminate in an arrow that looks like this big white block letter. So this one connected. I'm also going to add 2 product streams. And I'm going to not connect this one properly. So you'll see how this one, both ends of this are the white blocks. I'm going to go back to mouse mode, and this stream I need to connect it to my device here. So I'm going to right click and say reconnect, and I want to reconnect the source of this stream. And so I do that, and it automatically connects it for me. So I have the picture right. I'd really prefer names other than S1, S2. Those are not very, informative. So I can rename these things. And I can do this in 2 ways primarily. One is I can double click on that block there, and you'll see that it brings it into edit mode. And I can change this, and I can name this feed. And I can do the same process and call this one vapor. But I also have the option of I can come down and anywhere on the line and right click, and instead of choosing reconnect, I can choose rename stream. And this is my liquid. I can also rename my block. You can name it anything you want. You can name it Sam if you'd want, but I think I'm going to go with something a little more descriptive, Flash. All right, so we have our basic setup here. I'm ready now to start entering the given data, but I think this is a good time to save. And so I will save and you see that I've already done this once. So I named it and I've saved it. My recommendation is that you save, I call it early and often. The back button, it has one, but it doesn't necessarily do what you wanted, and it will not reset the calculations in the way you expected. So as you progress, I recommend that you save, and if you're going to save it again later and you're not sure that what you just did is really a good thing, you might want to go back to the original version, then just keep resaving it with new names, okay? That's one of my best tips I can give you in using Aspen. Don't be afraid to save it too often and with too many different names, and then you can go back in and delete all the versions of the file that you don't want. But when you've made a mistake, you can go back to something that was working rather than having to try and boost life back into a corrupted simulation because of some error you made. Now let's look at our feed stream. So I'm going to double click on this. Well, I didn't mean to double click right on the arrow, anywhere on the line but the arrow. And it will allow you to start entering the given information. Now in this particular case, I know that I have mole fractions given, and it was 30% methanol, which means it must have been 70% 1,4-dioxane. I know that the pressure was 1 atmosphere. Be sure you get your units right. They said that the flow rate was 100 kilomoles per hour. But I still have that little red block. I don't have other data, so I need to enter something else, and the temperature is one choice. I could choose other things, but I'm going to choose temperature, and I'd like it to be near where I think that the flash is going to appear. It's really not going to make a lot of difference for this particular problem. In reality, you ought to know the temperature of your feed, but I'm just going to guess based on my VLE data that 75 degrees C is a reasonable guess of what the temperature will be for my flash. All right, so I have my feed stream. Everything seems happy on that. I never want to specify my product streams. I'm going to specify anything that I want about those in the block. So let's look at our block, and I can do it here or I can double click in the flow sheet. Either way. Let's just look at accessing it from here. So the flash type. All right, the pressure I know was 1 atmosphere, so 1 atmosphere. And the temperature. Again, we don't know that. If you do go back and look at the data, it looks like 30% is going to be, somewhere in here. So I just looked at these numbers and said, let's go with 85 degrees. I don't know. It's a reasonable guess. And this is where I want to actually satisfy the problem. Okay. So I have this. The flash seems happy. All right. Run is now highlighted in blue, so I can click run and run the simulation. And once it finishes, I have the results summary. I can look at my stream results. And what I see is that I have a liquid and a vapor stream. Okay, they're at 85 degrees. The molar flow rate is 78 kilomoles per hour of liquid and 21 kilomoles per hour of vapor. I got those proportions just about opposite, right? I really wanted this to be 20% and this to be 80%. And so what I can do is I can go back into my specifications and change the temperature in the flash block and till I get the right answer. Okay, so that's doing it by trial and error. That's probably not the optimal way of doing this. But I do have something that works, so I'm going to take this as an opportunity. I'm going to save it just as the same name. I'm not going to do a save as new because I'm happy with what I've got. I'm going to come back here, and what I want is, if this machine is so powerful, this software is so powerful, can't it do the trial and error for me? So we're going to do a couple of different things. One is the results summary, the streams. This was sort of painful digging through all of this. And like if I wanted to see mole fractions, I needed to click and open that up, and not happy with the way that that worked. Therefore, what I'm going to do is I'm going to do custom results summary. Okay? So looking up here, okay, so make sure that you've got the stream summary open and hit select properties. And what this will do is this gives you a list of things that you can be sure that are shown or are not shown. These are the list of things that are actually already in there. And maybe it's that I don't want mass vapor fraction, I want molar. And so you can choose these things. You can, maybe this is very important, so I want to add this at the very top. I can move things back and forth. I maybe don't want to see the mass vapor fraction or the liquid vapor fraction. Well, actually, it's not going to let me remove those particular ones. But I can choose some of these and I can remove them. And you can choose things and move them around. So molar flow, these are really the key properties. So let me just put those up at the top so I can check them a lot more efficiently. Okay? Once you've got it the way you like, you can also go through and add other variables, but you can do this and you'll see that it's going to show me the molar flow rate and the mole and liquid vapor fraction if I want those, or whatever it is that you specified. But it moves them so that it's easier to quickly scan your results. If you're going to do trial and error, that's really important. For the rest of us, we're going to force this to do our trial and error for us. So go back to the Home tab. And on the Home tab, we're going to look again at the Analysis group. This time we want to choose Sensitivity. Okay? Sensitivity really is synonymous with trial and error. What it's going to do is it's going to change a variable and see the effect of that. Okay? Which is trial and error. So we're going to click on that, right? And we want to do a new one. You can rename this whatever, but practice. Okay. And you need to fill in these three things. So I'm going to vary the temperature in the flash drum in order to meet the problem specifications, those things that I wish I could have specified in the outlet streams. And then I'm going to tabulate this so that I have a way of looking at my results and figuring it out. All right, so vary. I want to vary the temperature of the flash drum. Okay, so I'm going to do a new variable. Okay, variable 1 is fine. I'm going to rename it though. Let me call it temp. Okay. Doesn't like that. Okay, my manipulated variable is going to be the temperature of the flash drum. I'm going to tell it down here what this is. So I'm going to have to dig through all of these things here. I want the temperature of a block. Okay, this is a block variable. I have to now tell it which block. I only have one, so that's easy, flash. And which variable? Well, I want the temperature. There we go. I'm going to do it in units of C. And based on the data diagram, I know that it's going to be somewhere 80 to 100. Probably 100 is ridiculously high. And then, I don't know, how many points do you want? I did 60. Okay. It seems happy with that. So I'll move to my next tab, Define. All right. What I know is that I want to look at the mole fraction of methanol to be 20% methanol in the liquid. And I want to look at the molar flow rate. Okay. So these variables, variable name, lick for liquid. I don't want to confuse it with my stream name. All right. And on this one, this is going to be a stream property. Okay. I'm wanting to do the mole fraction in the liquid stream. Mixed simply means it's going to look at both liquid and vapor if they are in combination. And I want to specify it in terms of methanol. All right, so that one's fine, but I also need a second variable, and this is about the vapor. And on that one, okay, this one is also a stream variable. I'm wanting to specify the flow rate of this variable. It's a molar flow rate of the vapor. I want kilomoles per hour. And okay, just not happy with that, and I really didn't want to specify the methanol. I wanted it for both. Well, and then we'll go to Tabulate. Okay, the easiest thing to do is just say fill variables, and it'll just put them all in there. Okay. I've done this. Now I can say run. It'll take a little while. Okay. I want to look at the sensitivity name practice results, and it shows me these. And you can go through and look at these until you find the one that most closely matches. For our case, looks like somewhere in here is going to be that 20% that we were looking for. Okay. Now, how does this match? It's actually not a great match for what I was wanting to do. I really, if you look at just using a material balance with actual physical data, you find that the liquid flow rate is going to be more like 70.6 and the vapor is 29.4. If I use my results from this and come in, I'm going to leave my sensitivity now. I use that as a tool. And let me come in and, oh, here's my feed. I don't want feed, I want my block. Okay, if I change this to 86.75, which looked like a pretty close match to what that came out with, and run this, and look at my streams, you'll see that it's really not very close to what I actually wanted. In reality, if I do it from data, this should be 70.6 kilomoles per hour, and this should be 29.4. The error with this is not anything that Aspen is doing wrong. The error is due completely to our choice of method. So we'll come back and look at how I can improve those choices in a future lesson. Thank you.